Hello and welcome to the GeoDict 2023 Advanced GeoPy workshop. Before we start, please make sure that GeoDict is running on your machine. That being said, as we're using the Math2Market cloud this year, I'm not talking about your local computer. Please make sure you have logged into your cloud account, started your cloud instance, and have GeoDict running on your virtual machine. If not, please do so as soon as possible. You still have some time. Also note that if you at any point you are lagging behind, or if you do not want to follow the workshop interactively, you can also find all the results that we are producing during the course of this workshop in a subfolder of your workshop material folder named M2M Results. So let me introduce myself. My name is Dominik Michel, and I did my diploma in industrial mathematics in 2003. Finished my PhD in 2006 in geomathematics at the University of Kaiserslautern. I have been involved with software development and project management in the meantime, and are now an application engineer at Math2Market as of last year. After attending this workshop, you will be able to access simulation results programmatically using GeoPython. You will learn how to structure your GeoPython code into functions, which is very helpful when doing automation. We'll also show you how to perform simple automatic material optimization loops. You will learn how to create custom PowerPoint reports based on your simulation results. This workshop consists of 3 parts, where each part is roughly half an hour session, followed by a 10-minute break. During the whole workshop, my colleagues will be available in the chat to answer your questions, and I will also be available in the break time after each block to answer questions orally. In the first part, we are going to be recording a macro which generates a simple grain geostructure and runs a flow simulation. We will then extend that macro in order to access the produced GDR file and extract the permeability value from it. We'll then learn how to reorganize that macro into functions in order to make it easier to reuse for the following steps. In step 2, we are going to be looking at loops, that automatic material optimization and that plot generation. In the third part, we'll put all this together and create custom PowerPoint reports from our simulation results. One of the most important concepts in GeoDict automation is the so-called command. Almost every action in GeoDict is a command. For example, loading and saving files, structures or results, starting a simulation, or rendering an image or a video. Each command consists of a name and a set of parameters. For example, the result file name, the boundary conditions when running a solver, the solid volume fraction when generating a structure, and so on. Almost all actions in the graphical user interface execute a corresponding command in the backend. When you record a macro, this macro will simply consist of a list of these commands together with their parameters. When playing back this macro, it will run the same commands with the same parameters again. Also note that macros can have variables, which can then be defined in the graphical user interface. But please see the beginner's workshop for GeoDict macro variables, because we are not going to be using them in this workshop. Now, without further ado, let's just dive right into it. You can find the workshop materials on your virtual cloud machine. It is hardwired into every cloud instance being started. If you're not familiar with Linux, don't worry, our usability workflow will feel similar soon. The workshop material can be found in the virtual cloud machine, in Home, and then My First GeoDict project, wherein all workshop materials are provided, here called User Meeting Workshops. The folder for this workshop is included here too, and should be called Workshop GeoPy Advanced, or at least comparable. The first thing I would like you to do is to change your project folder to a subfolder of this folder. Namely, in GeoDict, go to File, choose Project Folder, select Project Folder, then go to Workshop GeoPy Advanced folder and go into Project folder. This is an empty folder prepared for our results. Now the next thing I would like you to do is go to Model, Grain Geo, select Grade Grains, and then go to Edit and change the voxel size to 100 x 100 x 100 voxels. And click OK. And then click Generate. There should probably be a result viewer popping up on your screen. You can just close that for now. Next, choose Add Binder from the drop-down menu and click Run. This will add some stuffing in between our grades. You can close the result viewer here too. Next, go to Predict, FlowDict, select Stokes-Brinkmann, the first option down there, and click Run. This runs a flow simulation on a small structure which should be very fast. Again, you can close the result viewer. Now we are going to be looking at the session macro. You can access this by going to Macro, Session Macro, and as I mentioned earlier, GeoDict keeps track of the list of commands that have been executed, and you can see all the commands that have happened here since the start of this GeoDict session. Namely the GrainGeo commands, GrainGeo create and GrainGeo add binder that we did, and the solve Stokes command here. So the first two are the structure generation, the third one is the flow simulation. Now we want to create a macro from these three steps. So we select GrainGeo create first, then we hold Control and select add binder and solve Stokes as well. All the other commands here are not important. For example, load GDR file is opening of the result viewer, and the close all GDR files is the closing of the result viewer. So we only take these three commands, select them by holding Control and clicking, and as of GeoDict 2023, then we click the downward arrow button in order to add selected commands to file. Basically what we have here is like a staging area, where we can move individual commands in order to then write them out to a Python file. To do this, we go to Save and we name our file workshop1.py. As you can see, we are in the project folder and it gets saved here. So click Save and we can close the session macro for now. For those not familiar with Linux, have you noticed any difference to Windows yet? No? Good. Now let's go and look at the custom macro that we just recorded. For this purpose, go to the macro menu, go to Execute Macro Script, unfold the project folder if it's not yet unfolded, select workshop1.py and click Edit. This will open the macro in a text editor. In our case, this is Notepad QQ, a Linux equivalent to our recommended text editor Notepad++. As we are on a virtual machine, this may actually take a few seconds. As you can see, there are several prologue blocks in the macro here, which are GeoDict specific. Now we'll go through them one by one. First of all, we have the header. The header gives you the GeoDict version which this macro was recorded, the time and date when the macro was recorded, the username of the author and the platform on which it was recorded. Then there's a description text, which is a multi-line string that you can edit freely, and this string will be shown in the Execute Macro dialog. So the purpose of this string is basically to describe what your macro does to other people that might want to use it. Then there is a variables block. As I mentioned earlier, we are not going to be using variables here. But in this block, you could give your macro additional variables, and the user which executes the macro can set the values for these variables directly from the user interface. There's also a large comment block which explains a bit on how to use these variables. This is basically the header of the macro. These are GeoDict specific blocks, and this is followed by normal Python code. Note that in Notepad++, you can fold and unfold sections by clicking the small plus minus next to the first line of each section. We will use this a lot. When playing back a macro, the body is executed from top to bottom. Namely, there is an argument block for each command, followed by the actual command call. This argument block is a Python dictionary which consists of key value pairs, as you can see, in a structured manner. So there's a hierarchical structure to it, and you can actually fold these blocks together if you're using Notepad++, which we suggest. For example, I can fold these blocks by clicking on the minus sign here. I can basically collapse one part of the whole tree, and likewise I can also collapse this whole block of parameters. Now this is much easier to see what is going on. We have a definition of arguments for GrainGeo, followed by the actual command indication. The same holds true for add binder, even though the list of parameters is rather small here. And of course this is followed by the flow simulation. These are the flow solver's arguments. For example, you can see the name of the result file which we are going to make use of later. You see the solver selection, the Lear solver is selected, for example. But for now I will also just fold this away by clicking the minus sign. Now we can see the actual structure of the macro. So we have a GrainGeo GeoCreate command, followed by GeoAddBinder and the FlowDict solve Stokes command. Next, let's take a look at the floating simulation results. I know we have just closed it, but let's open it again. We'll go back to GeoDict, and here we go to File, Open Results. Then we select the Stokes result file, the GDR file, here in our project folder. This will open up the result viewer, which shows us some data about the flow simulation. You can see here that we have a permeability tensor. Because we computed the flow in Z direction, we might be interested in the permeability in this direction, which is the value which you can see in the user report here. But if we want to access that value programmatically, we have to find it in the result map. The result map can be found under the Result tab in Map. If you go here, we can find all kinds of structures, hierarchically computer-readable data, which gives us the flow simulation results. If we look through this, we can see that there is a permeability 3,3, which is the permeability in Z direction here in the result map. What is important here now is the name of the key, namely permeability 3,3. We know that key, then we can continue and access that value programmatically. Now, in order to do this, go back to Notepad++ to the file workshop1.py. Now, the first thing, please save the file on a different name. Go to File, Save As, and save it as workshop2.py to keep the previous results. Now go down in the code to the solve Stokes command, or rather to the line gd.run command floating solve Stokes. And here we go and write gdr_name equals in front of that line. What this does is that the run command returns us the name of the GDR that was just generated. We can use that to open it afterwards. Then we do import string map. This loads a library that we need to open GDR files for. Then we write GDR equals string map dot pass GDR in brackets GDR name. What this does it opens this file and passes the content and saves the content under a variable called GDR. Now what we want to do is to extract the permeability value, which is stored under the key permeability 3,3 in the result map. To do this, we do the following. We write perm equals float in brackets GDR. Now that you can use single quotes or double quotes interchangeably, but not mixed in the same string. But we could have also used single quotes here, of course. Then we go and continue result map double permeability 3,3 and closing it. What this does, it gets the value for the key permeability 3,3 in the result map. There are also different maps. There's, for example, also the input map, which gives the input of the command. But result map is the results. So we go to result map, permeability 3,3, get that value, and these values are always strings at first. We convert them to a float value here, because it's actually a floating point number. Then we go gd.msgbox in brackets perm. So after the value is stored in perm, we then display it using message box. This is a special GeoDict function which opens a dialog box which can show any text, basically. At this point, please make sure to save the file by pressing Ctrl S. Now we go back to GeoDict and go back to the macro execution control. If it is not open anymore, just go again to the GeoDict user interface. Go to macro, execute macro script. There you should find workshop2.py. If it's not there, you might have to click refresh first. Now we select workshop2.py and click run again. If it asks us to override, just please click override in the center. The question comes up because the macro generates the grain structure again and runs the flow simulation again. So it asks us what to do with the old GDR files of the same name. Now we see that the permeability number has been outputted in a message box at the end of the macro. So what it did is it generated a structure, ran the flow simulation, then it opened the resulting GDR file, extracted the permeability value and showed it to us. Let's again go back to Notepad++ to the workshop2.py file. Again, we save it as workshop3.py. Now what I want to show you is how you can reorder this code into functions in order to make it more reusable actually. We start by going above the line create args1 and introduce a function definition by writing def create structure and run simulation and then SVP in brackets. This introduces a function that is what def does. The function is named create structure and run simulation because that is what the function is going to do. This function gets a single argument called SVP. This is for solid volume percentage, as we will see in a moment. Now, one more thing we need to do is the following. Python knows where the function ends. We need to indent the code, which is supposed to be part of the function. So we take all this text, and as you recall, this corresponds to a lot of text here if we unfold it, but we can keep it folded. We just take all this text, mark it, that is the create args and solve Stokes command, and press tab once. That tab will indent the code, and now it will also unfold it automatically, but we can fold it back again. What this indentation signifies to Python is that this text block, is supposed to be part of the function. That means this line import string map is not part of the function anymore. When this function is called from somewhere, just this part executes. Now, as you probably know, the grain geostructure generator usually works with the goal of reaching a certain solid volume percentage. So that's basically the opposite of the porosity. Give, for example, a solid volume percentage of 10%, and then it will try to fill the volume with 10% of grain material. Now what we want to do is we want to extend this function, so we'll take this SVP value and train the structure with the given SVP. As we have recorded the grain geo call earlier, it currently contains a fixed solid volume percentage, as we will see. So unfold this create args1, and we will scroll down and see solid volume percentage. Again, this is a key value pair. So we have the key solid volume percentage here, and then a column and the value here. This value can optionally contain a unit. In this case, it is %. So when you read this, you will know that this is a percentage value. As you can see, there's a fixed value of 35 recorded here. Each time this grain geo runs, it produces a solid volume percentage of 35%. Now, if you write instead SVP, then it will insert the value of this SVP argument that we introduced in our function in the place of the 35% that we had earlier. Whenever this function is now called with any SVP value, it will first generate a structure with a given SVP and then add some binder and run the flow simulation. One more thing that we would like to do in order to keep our results separated is we want to make the result file name also a function of this SVP value. So we go and find the result file name line here, which is called graingeocreate.gdr, which is a default for graingeocreate. And we add a small f in front of this first quote. We write instead of graingeocreate.gdr, we write graingeocreate underscore curly brackets svp.gdr. And this will do is will actually introduce this svp value as a part of the file name, as you can see. So it will take the svp and insert it in this part of the file name. Likewise, we do the same with the add binder and the solver argument. We go down to add binder args, unfold that, and there's also a result file name. We go add an f in front and to add binder underscore curly brackets svp. Now we go down to solve Stokes args, unfold that. There's also a result file name, and we go add an f in front and do Stokes result underscore curly brackets svp. Now each time this function is run, it generates a graingeocreate 50.gdr, the add binder 50.gdr, and the Stokes result 50.gdr, for example for an svp of 50. But right now, as this code stands, nothing will happen because the function is never called. Note that extracting the permeability needs to be intended too. So it will also at the end of the function extract the permeability value. But instead of displaying it, we now do return perm instead of gd message box in perm. Now we have a function which creates a structure, runs a flow simulation, and gives the permeability back, all for a given solid volume percentage of the structure. Now that we know what this function does, we go up here all the way up to the function, just fold it away by clicking the minus in front of the def. Now next, what we do is we actually call our function. We do perm equals create structure and run simulation, and we give it say an SVP of 25. Then again we open the box showing us the resulting permeability. Now this calls our function, gets the resulting permeability and shows it. Now let's save this file again by pressing Ctrl S. Let's get back to GeoDict to try it out. Go back to the macro execution dialog again, click refresh here so we do see workshop3.py, select it and run. We now get the permeability for the new structure with an SVP of 25%. We can see what we have. If we close the macro execution dialog, we go to File, Open Result, we can see that we now have a grain geo25, add binder 25, and a Stokes result 25 GDF files here, which correspond to the structure generation and the flow solver results. Now we have to find a function to encapsulate most of the work we are doing. But as we use the two-part structure generation, namely grain geoCreate and grain geoAddBinder, we should introduce a second variable from the binder SVP. Similar to the previous cycle, we add a variable called binder to the function definition. And we look for and place the default 10% solid volume percentage in addBinder args1 and add binder to the file names, namely in create args1, similar to the previous SVP inclusion, in addBinder args1 and in solve Stokes args1. Now the function will generate a structure with a given SVP and binder addition, run the simulation, and save the results under meaningful names. Now let's save the file again by pressing Ctrl S. Let's get back to GeoDict to try it out. Go back to the macro execution dialog again, click refresh here so we see workshop3.py, select it and run. This will result in an error message as we currently call the function with one variable only. Going back to Notepad++ and inspecting this function, we go up here all the way up to the function just folded away by clicking the minus in front of the def. As the function has two variables, now we have to change the call to the function on the top level to cover the second parameter. Add a second variable to the function call, for example 15% of binder added. Store it again. Let's get back to GeoDict to try it out. Go back to the macro execution dialog again. Click refresh here so we see workshop3.py, select it and run. We now have a convenient function we can call to compute the permeability for a given solid volume percentage and binder addition. This concludes the first part of the GeoPy Advanced workshop. You have learned how you can record a macro, how you can access simulation results, and how you can reorganize the code of the macro into function in order to make reusable and make the structure generation parametric. In the next part, we're going to build on that and call this function automatically with different values in order to do a parameter study. If you did not quite catch up, please feel free to go to the M2M results folder and copy the intermediate files that we have generated here over into your own project folder, namely Workshop 1, Workshop 2 and Workshop3.py. Then we can build on that in the next part. Now there's going to be a 10 minutes break, so feel free to ask any question either orally or in the chat. Otherwise, see you in 10 minutes.